Today we want to look at a topic in physics which we know as electricity. What is electricity? Electricity simply means flow of current. Electricity means flow of current. And we observe it in our various homes, when your fan is turning, when your lights are on, when your DVD are playing. What actually happening is that electricity, there's a flow of current through the wire. And for electricity to flow, there are things that must be present. First, there must be a conductor in the form of wire. Conductors must be there. There must be a source of power, which might be BEDC for most of us here in Nigeria, Benin City Electricity Distribution Company, or Ibadan Distribution Company. And there must be source of power. Then the points must be connected, the conductors must be connected, and there must be a key. A key is what we call switch. Key or switch. Then and the key must be closed. If the key is not closed, closing the key means to on the light. That's a layman language, but in physics we call it closing of switch. When you open it, that means you on it. So when you don't, when these things are there and the key is not closed, current cannot flow. So that's the only scenario where current will flow. We look at the first thing, their Ohm's law. Ohm's law. What is Ohm's law? Ohm's law says that the current passing through a metallic conductor is directly proportional to the potential difference, provided that the temperature and all other external physical factors associated with the conductors are kept constant. There are key things you must have to take away if you're going into an exam for the definition. First of all, current passing through a metallic conductor. Remember when you said current can pass through other things like electrolyte. In that case, we have what we know as Faraday laws in our chemistry. But when you talk about metallic conductors, you talk about things like copper wires, silver wires, and all that. So metallic conductor must be there. So if current passing through a metallic conductor will not be directly proportional to the potential difference. Then also remember there's always a caveat, provided that the temperature. So these are the factors that will affect the flow of current, which maybe we'll treat in our next topic. So what is the statement? That the current passing through a metallic conductor is directly proportional to the potential difference, provided that the temperature and all other external physical factors associated with the conductors are kept constant. Mathematically, you see, physics is close to mathematics. That's why anytime you ask us to measure, you see mathematically. Mathematically, V is directly proportional to I. That's what we are saying. Current passing through a metallic conductor is directly proportional to the potential difference. V is the potential difference. Anytime we want to remove this, we introduce a constant, which we call R. And that R is known as what? The resistance. So this is the statement of Ohm's law. V is equal to IR. It can also be accepted in the exam condition, but in the exam condition, if they ask you to define Ohm's law, you say that Ohm's law states that V is equal to IR, where V is the potential difference in volts, I is the current in ampere, and R is the resistance in ohms. You score the same mark with somebody who has just used grammar. So that is the statement. Then, for instance, we look at a simple question that has to do with this. Example 1. Let's take out one example. A current of 2 amperes flows through a conductor of resistance 5 ohms. Calculate the potential difference. The potential difference. Solution. From the statement of our Ohm's law, we say that mathematically V is equal to what? Mathematically IR, where I is the current, which is what? On the board, 2 ampere. R is the resistance, which is what? 5 ohms. V is unknown, that's what we are looking for. So when we substitute that in that equation, we have V is equal to 2 times 5, which is 10 volts. The unit of potential difference is 10 volts. This is a very simple example. In our subsequent editions, we'll look at higher examples and arrangement of the system. So I hope you do enjoy the class. Please comment, like, and follow for more. Thank you.